In this recording, we are going to talk a little bit about layers and components. So you can often find layers or tiers in almost all parts of software engineering problems. So it's a basic way to divide almost anything into different types of layers or tiers. So the problems that you want to solve is that you would like changes to be confined so they don't spread uncontrollably all over the software. You would like to have exchangeable and reusable parts, and you often have a need to divide work, so you would like to use experts in some regard. So you would like the experts to work on the parts that they are actually experts on. And the solution to this is to try to divide the system into some form of coherent layers of responsibility, and let the higher level layers, the more specific layers, depend on more generic lower layers. For example, we have our model classes. They in turn depend on a more generic set of classes that represent an object relation mapping. So some way to map our nice model classes into a data saving layer. So our specific classes depend on these more generic libraries, the object relation mapping library, which in turn also depends on some even lower level library that uses, for example, SQL to save data in a database. You often hear the terms relaxed or strict layer style, and in the strict layer style we enforce that you can only depend on the layer next lowest to you. So the model can only depend on the ORM layer, but not on the SQL layer, so no layer skipping. In the relaxed style, we can have layer skipping, so the model then can depend on SQL, and sometimes this is needed, maybe for performance reasons, or maybe the ORM library did not offer some type of functionality that we needed, so we need to use SQL directly in our model. This of course has some disadvantages, because if we change the SQL to something else, both the ORM layer and the model layer are likely affected by this change. So if we enforce a strict layer style, then it's often easier to modify the architecture by switching one layer for some other implementation. If we have a relaxed layer style, we sometimes lose a little bit of that flexibility, and changes may be ripple through the system in unknown ways. One problem we often find in layer designs is that you need some type of backcalling. So the ORM layer needs to depend on something in an upper layer, and that's of course not a good idea, because this would mean that the model and the ORM in this case would be very tightly coupled to each other, and the ORM cannot be reused, for example, without also reusing parts of the model, and this is not what we want. So if you have this situation, you need to use some form of dependency inversion, for example using callbacks and maybe the observer pattern. In this example, we see a classic 3-layer or 3-tier design, where we have 3 different views of the architecture. We have the hardware view, the process view, and the development view. So in the hardware view, we discuss hardware stuff. For example, what type of client computer are we talking about? What performance characteristics and stuff does this client computer have? Servers for running different services, for example, a database server and things like that. And also the types of connections between these. In the process view, we discuss more about what processes are running on the hardware. So on the client computer, in this case, we run a web browser, and we can discuss characteristics of this web browser, what the type of compatibility and things like that it needs to have for our system to work. And we also talk about what type of processes are we running on the server. In this case, we are running a node process. and also what type of database are we actually using here, in this case MySQL. We also have the development view. Here we talk more about what is actually happening in our application, and we will have a presentation layer that is responsible for showing something in the browser, and we decide that we will use JavaScript, React, HTML and CSS in the presentation layer to present information and offer interaction for the user. We also have a logic layer. This will be implemented in TypeScript and it will run on the node in the node process. And for the presentation layer to communicate with the logic layer, we will develop a REST API. And we also need to save some data, so we have a data layer, and for the data layer we use an object relation mapping so that we can save data, and the data layer uses SQL to communicate with the MySQL process. So in this way we can reason about systems from many different views, and so that we don't mix views and talk about different things, we can focus a little bit more. But this is a classic 3-tier design. You can often find it in many types of systems. So onwards to software components. A software component is something that is built and deployed. So it's something that you can actually run on a system. So it is something different than the source code. It's the running representation of the source code, and it's often a lot larger than a single class, for example. We can see it as a sub-part of a running system that we can exchange. So the idea about software components is that we would like to compose our system out of well-tested, well-designed and implemented reusable software components. So instead of programming source code programming with classes and things like that, we use different components instead, and we configure these components and we compose them into a working system. So it's a higher level of reuse and a higher level of developing than basic programming. So components can offer different types of APIs, different types of services, and also libraries can be thought of as components. There are special technologies for components and for handling components: Jigsaw, Java Beans, Decom, Corba. There has been a lot of work done here in that regard. We will take a small example look and see how we can use basic components in Java to compose our little dice game in 2 different ways. So I have modified the dice game a little bit by creating 2 different types of views. We have our classic console view, just as we had before, but I have also created a graphical user interface view. Otherwise, the game is basically as it was before. We have a model with the dice game itself, the dice roll-up server interface, and the die class. And we have the application class and the play class. One change that has been done is that the view is responsible for actually creating the concrete view that should be used. So we have an interface for the view that the controller uses, and we have a factory in the view that creates the concrete implementation of this interface. This means that the app class first creates a factory and then gets the view from the factory. So the whole controller package is decoupled from the concrete implementations of the view. We will actually not use the compiler and build stuff from Visual Studio or what IDE you are using. We will use the command line tools provided by Java, and you will see a little bit more how that works, and we will package our compiled class files into components, and we will compose these components into a running game. So first we need to compile stuff, and we have our source code in the source folder, so we can use the Java compiler, javac. We will specify what it should compile, src model and it compiles the Java file. We also specify the output directory. So we would like the compiled files to be put in the out directory. So let's take a look what we got. We got the out directory, we got the model package, and here we have the compiled class file. So this is the bytecode that the Java interpreter actually uses and runs the code. But of course we need more than the model to run things. We also need a view. And let's start with the basic console view to start with. So again, we compile, and this time we want the view. And as we have a sub package, we need to specify this also. And we also want this in the out directory. And finally, we want the controller. So again, we need to compile things and have it in the And as you saw before, we could compile the model and the view without problems. But when we tried to compile the controller, you can remember that the controller actually was dependent on both the model and the view. It uses the model and it uses the view. There were no dependencies from the model to the outside, and there were no dependencies from the view to the model or the controller. And it actually means that we cannot compile the controller without also telling the compiler that, all right, the model is here and the view is here. We can do that in Java by using the class path. So it tells Java where to find other source code parts, so to speak. And in this case, we know that everything is in the source folder. So that compiled nicely, and this is also an advantage of having less dependencies. We can easier package things into nice components, and we can compile things separately from each other. So if we go to the out directory, we have the controller, we have the model, and we have the view. So the class files are things that can run. So we can basically tell Java to run this application now. By simply specifying the main class. And as you remember, we play the dice game and we have 3 different dices. All right. Distributing class files, that's maybe not that nice. So we will package these class files into components. And the simplest type of component in Java is the jar, the Java archive. So we can use the jar command to package our compiled class files into nice components. So jar So this basically tells jar to put the stuff in the model package into model jar. This was done and we got the model, and let's do the same thing for the view, and let's rename this component console view so we can keep track of it. And finally the controller. Now we have our jar files, and let's move them to the directory above. let's remove our output directory. So we have no output directory, but as we have the components, we can still run our application. So here we are telling Java to have the class path. So look in these jar files for your classes when running the system. So we are basically composing our system out of these three components. Again, supply the correct main class and we can run the application. Now for maybe the interesting part, let's develop a new view component. And as I prepared this, it's quite easy because we only need to change the factory and have it return something from the graphical user interface instead. And as this class also implements the view interface, everything should compile and work as before. So let's create the new component. First we compile. And we need to take the view. And we need to take the graphical user interface this time. Apply the output directory. And now we have the view. Let's create the component. Like so, and let's move it. All right, now we can compose our system again, but let's not use the boring console view. Let's use the new graphical user interface view instead. So we compose the graphical user interface view component with the controller component and the model component. And we get this nice graphical user interface instead. So it works exactly the same, but it presents a graphical user interface instead of the, maybe I will win, oh no. Instead of the little bit boring console interface. You can of course imagine that we can have different teams working on different types of components. We can have different combinations of dices and rules in the model, and we can still compose these new games out of our components instead of compiling and running every combination of the games in source code, so to speak. So that's an example of simple example of components in Java, and this is the most basic type of components you can imagine, and there are different types of technologies built on top of things like this.